and we will show you and then discuss to you our simple prototype of the rotational kinematics, which is the gyroscope. Please settle down and listen to Spark along with my members as we explain the nature, principles, and benefits of gyroscope.
So, are you ready all? So, let's get things done. So, this prototype is a simple gyroscope. So, gyroscope is a precise instrument that is used to measure and maintain orientation by utilizing the principles of angular momentum. So, it was invented by Johann Bogenberger in 1817 and later improved siya and modified pa dun siya ni Leo Foucault in 1852. So essentially, it consists of a spinning wheel or a disc that is mounted on a base that allows it to resist change in its orientation. So gyroscope works by utilizing the principles of angular momentum. So when the gyroscopes spin rapidly fast, okay, I want you all to imagine. Spin out fast, and it creates a force. It creates spinning fast, and it creates a force that allows it to maintain its orientation. This property allows it to maintain alignment in space. Making it useful for applications like navigations and stabilizations. Essentially, the gyroscope spinning motion helps it stay steady and oriented or well balanced, even when the surroundings are moving or changing. Its still will balance. So as you can see, our DIY simple gyroscope is made up of two CDs, one tube, motor, and one battery. And then put it all together, then you have acquired a simple gyroscope. So now, for the most exciting part, I want you all to watch carefully. So our group will demonstrate how the gyroscopes work. So imagine only a seat or compact disc.
Okay.
Without a motor or rotational motion or gyroscope. Observe what happens without the gyroscope. Hala, it fell. Did you get what I mean? So guys, so you see, it quickly falls without a force. It falls. So again, so a gyroscope when spinning rapidly fast, it creates a force. Okay. So now I'll on our gyroscope. Okay.
Let me just ask. You always say force. What happened to the force? It is acted on the system or by the system? And if there would be a force, what type of force that is acted on that particular perspective? External torque with respect to the force that is acted on your prototype? Or what? if it moves fast, therefore, if it moves fast, there will be a uniform circular motion. Wherein there is a center of the mass with respect to its ranges with the whole circumference. Diba? So, since it is rotating, it maintains a uniform circular motion. But my question is, what forces that is acted on that particular perspective? Like you see a map? What do you think? Alam ko niyo siya, class. If the system is rotating, therefore there is a work done on the disk for it to maintain its orientation, which is to stand, right? But if we must have to understand if there would be work, there should be a force with respect to the displacement, or the force is perpendicular to its displacement. So that is why if it rotates, therefore there is a displacement covered in a uniform circular motion as the center towards the radius within the whole circumference. Diba? That is why we have this what they call as the angular accelerations or the angular velocity or even the angular momentum that is just summation of all the energies that is acted on that particular perspective or system. So that is why I asked you what forces that acts on your prototype that it maintains its orientation to keep it balanced. Why?
Ito
Ang external force na muna siya yung pagtuyok niya sir. Force niya sa pagtuyok sa water.
Pagtuyok.
ang wind force sa
So therefore, the external force
muna nito sa
has a collision between the two discs or not? Ang disc ba is stationary and the other one is motoyok. What's the purpose again ng motoyok na siya diyan yung kinalasan mo as steady? To maintain its stability. So therefore, to maintain its stability, it should be that the rotating body must be in uniform circular motion or constant in order to maintain its stability. To maintain its orientation based on the moment of inertia on which it has mass. Okay? Sige, pala yun.
Guys, here. Sorry, Lunan. As you see, it quickly falls without a one to you. So again, so this one is now with a motor and battery and additional disc. So look, listen, and listen. Come on, look. Listen.
Chewy kayo na.
Look. This one happens.
Uy!
See, physics is amazing. Now, let LG go your part.
So, you guys might
Si Awa din. Sige, sa wala lang.
So gyroscope is one of the inventions that mold our world into what it is today. A gyroscope is used to measure or maintain orientation like what yung sulting kanina or angular velocity. It is a spinning wheel or disc. in which the axis of rotation
Ang
is
Gyrus ko
free
pala,
to
pareha raw
itself.
dapat siya. Ha?
It helps stabilize and orient objects such as spacecraft, drones, ships,
Pareha raw tingali.
airplanes, and even your smartphone. So by detecting the changes in orientation. So although most of us humans don't know what the gyroscope are used for, gyroscope is the one of the most important inventions that discovered and invented. So gyroscope are crucial for navigation systems, helping vehicles and devices maintain stability and direction, even in turbulent conditions. So one of the example of this is kanang ship, kanang barko, and di ba, namjay instances sir nga maksud na to bagyo or bad na weather. And due to kanang bad na weather, kusog kaya ang tuyok sa hangin. And if kusog ang tuyok sa hangin sa dagat, makabuo og typhoon. And before mabuo ang typhoon, di ba, kusog hangin. So kusog sa kayo ang bulb. And kanang na bulb, muna siyang hinungdan ay muna siya abuan kanang ang effect na niya kay ang ship kay basta
even though I'm shapeless, even though there is a wave or that, the ship is not steady because it always maintains its buoyancy. It will constantly moving even though pag sige na siya move, dili lang kayo mo siya ma-feel. Ikaw, gamay kay ka, ang barko pagkita ko, But still, it will always be moving in this perspective. Because it maintains its buoyancy. So perhaps, on that particular perspective, makita niyo mo ba nga, the uniform circular motion is not in a linear perspective, but instead, it is on rotational perspective. Diba? Kaya may mga tanawon, kung linear lang, hindi mo makita kung asa sa padulong. Kaya kung sa dalan pa, kung straight traffic kaayo, hindi mo makitaan kung unsay kinalasan. Kaya layo pa man kaayo, straight man sa siya, wala makakaiba unsay pwede mo makagian. Unlike mga sa rotational, it could adjust or it could just blend based on its orientation. Amay na nasa sa pagpatuyok nila ganiha. Before siya nituyok, it still looked at within the axis. Kabaw mo ba ang seconds feeling? Pero kada lang, katulog ta ako niya. Parang similipit lagi na mata niya. Parang tumata mo paano parang nahalata na kita ko. Now, so if you just try to observe, ang gamay good nga disc, maugay nagtuyok. And then, the bigger disc,